Hi, this is Lakshmi Kantiwari. In this lesson, I am going to teach you feature selection based on Univariate ANOVA test for classification. In previous videos, I have taught the feature selection based on Univariate ROC-AOC test based on the mutual information or entropy gain and the feature selections after removing the constant, quasi-constant, duplicates and correlation features. But in this lesson, I'm going to teach you how you can select a feature based on ANOVA test. Although this is just another branch of univariate or filter methods. So initially I'll be talking about what is the ANOVA test and how it is different, the t-test, what is the difference between the t-test and f-test. Then I'll be going through a little more introduction. Then finally I'll talk about the feature selections of the sklearn library, and then I'll take you through the classification problem only in this lesson. I'll not take you through the regression problem. If you want to do the regression problem with the ANOVA test as well, you can go ahead and watch my previous videos, and this is the similar process for regression as well. So I'm working on this dataset. You can download from this given link. So basically it is the Santander dataset. On the Santander dataset, I'm just loading the 20,000 rows initially, just for the simplicity and faster processing. And then I'm removing the constant, quasi-constant and the correlated features as usual. And then finally I'm doing here the f-test. I'm selecting the features by doing the f-test. So I'm plotting here the p-values, and I'm just selecting all those p-values which have values less than 0.05. So in theory, this says that if your if your algorithm, if your test have a p-value less than 0.05, then those features are important features. And then finally, I'm building here a classifier, and then finally comparing the performance. So this will be the all in this lesson. So without wasting your time, let's go ahead and start this lesson. The feature elimination process aims to reduce the size of the input feature set and at the same time to retain the class discriminatory information for classification of the problem. The analysis of the variance which we are going to take in this lesson, ANOVA, the analysis of the variance can be thought of as an extension of the t-test. The independent t-test is used to compare the mean of a condition between two groups. Okay, although this ANOVA test is based on a f-test. F-test is any statistical test in which the test statistics has f distribution under the null hypothesis, and f statistics is kind of the extension of the t statistics. And here you can see the difference between the t-test and f-test. In the t-test, we compare the mean from the two groups, but in the f-test or ANOVA, we compare mean from more than two groups. For mathematical description, the mathematics for a t-test and f-test is given below. The t-test can be calculated from here, and f-test is variability between the groups divided by the variability within the groups. Okay, perfect. So the analysis of the variance is the collection of the statistical model and their associated estimation procedure. Okay, such as the variation among and between the group, and then it is used to analyze the difference among the groups. The ANOVA was developed by statistician and evolutionary biologist Ronald Fisher, and that is why it is also known as f-test. The ANOVA is based on the law of the total variance, where the observed variance in particular variable in partitioned into the components attributed to the different source of the variation. So this is the kind of the complicated the definition. You don't need to go on these definitions, but in the short, what we can say here, the f-test ANOVA is equal to the variance between the samples or the features divided by the variance within the features. Let's say we have a two feature, the feature 1 and the feature 2. It says that the variance between those two features divided by the variance between those amongst the in the feature itself. Okay, so these are the complicated definitions in the process. So the sklearn feature selection procedures has made these process very simple for us. We don't need to go ahead with these things. Okay, we only need to use the f-classif and f-regression. F-classif can be used for classification problem, and f-regression can be used for a regression problem. Okay, so let's go ahead and start working with the classification problem. In these lessons we will work only on the classification problem, and if you want to know about the regression problem as well, you can go ahead and watch at my channel there. So I have taken there the classification and the regression problem as well on these lesson. Okay, so for the simplicity I'm just gonna take classification. And initially we need to import the necessary libraries or the packages into the Jupyter notebook, and this is a repetitive process. That's why I have put these things into the Jupyter notebook instead of typing these things again and again, because in the previous all of these lessons, so I have been doing almost the same thing as I'm doing this one. Okay, so you only need to do the same thing, right? So the first here I am importing the train test split, then random forest classifier, then accuracy score, variance threshold, f-classif, f-regression, select k-best, and the percentile. And the data set on which I am working in this lesson you can download from this link. Okay, so from this link you can download this. And apart from that, once you download the data set, put the as Santander data into the same directory where this file is stored, then you can read the data, Santander data. I'm just reading here the initial 20,000 rows for the simplicity using pandas data frame, and it is read into the data and then printing the data head. So let's go ahead and run these. Okay, so it printed the data head. It says that there are 370 columns for a feature, and the last column is for the target. So there are total 371 columns, and then I'm taking these the feature vectors into x and the y. The x have a 370 the dimensions, and y is just a single dimension. And then I am going to do the train test split. Okay, so with the train test split, I'm splitting the data set into the training and the testing. Okay, and after that I'm going to apply the constant, quasi-constant, and the correlated features removal. And if you see that these sections I have been doing in almost in all of these previous lessons, and if you want to very detailed and in-depth knowledge on this, you can watch this lesson where I have taught there how you can remove the constants, quasi-constant, and the correlated feature. But in short, these lines of the code are removing the constants and the quasi-constant features, and it is just keeping the 99% of the variations, and it is removing the one if any features are less than 1%, have a variation less than 1%. And there now you see the dimension has been reduced from 370 to just the 245. And now I'm going to remove the duplicate features in these lines. So this is going the transpose, this is doing transpose, and then I'm creating pandas data frame out of the numpy array. And then here I'm just calculating the how many rows are the duplicate. If you have watched my previous videos, you will know that it always give you the 18 rows, because it's the same data on which I'm working, but with the different feature selections methods. Now let's go ahead and get the index for the duplicate features, and let's go ahead and get the index of those features on which we want to keep the features which we want to keep. Now we have got the index for the features which we want to keep. Now let's go ahead and start the F test. Let's go ahead and add few cells, and now this is the new things. Let's go ahead and start with the ANOVA. And with the ANOVA, what we can do, we are going to do first we are going to do the f classif. We are going to call the selector, the cell is equal to f underscore f classif, and I'm going to just apply this on x train underscore unique, the unique which we have got after removing constant, quasi constant and correlated feature. And then here I have y train. Now let's go ahead and print the selector, and once I print the selectors, it gives me, here you see the two-dimensional array. In the first dimensions it gives me the f score, and in the second dimensions it gives me the p values, that's the probability. Okay, so here what I'm gonna do here, by using f classif, I'm gonna calculate the p values. Okay, so in the theory, if p values are less than 0.05, then only those p values are very important. So now let's go ahead and calculate those p values. In fact, I have already calculated, so let's go ahead and take those values into a separate variable. Okay, so here we have a p underscore values. The p values is equal to the pd dot series, and there we have the second one. Okay, so the second array, which we can get by just passing 1, and the first array is we can get by passing index 0. And after this, what we can do, we can just pass the p values dot index is equal to x underscore train underscore unique dot columns. Okay, and then I can get with the p values dot sort values. Okay, the p values dot sort values, and I'm gonna sort it into the ascending order. So I'm just gonna put ascending is the true, and in place is equal to true. That's mean it will put the results into the p value itself. It says that there is some kind of the error, so let's go ahead and see what is the error. It says that has no attributes the columns. Of course it doesn't have these columns. Okay, now it is working, and after this let's go ahead and plot this, the p values. We can plot this p values, the p values dot plot dot bar, so in bar plot, and let's go ahead and give the size for the figure. And here for the figure size, I'm gonna just put 16 cross 5. And if we see here, the theoretically we should take only those p values which have values less than 0.05. And if I plot this p values, you see here there are only the few values which have a values less than 0.05, and that I can get values which have 0.05 like this. And you see these are the values which have less than 0.05, and the length of these values are 88. So the 88 features out of the 245 have a p values less than 0.05, and theoretically these values are very important. But if your data set is too high, okay, then the having extremely low p values doesn't indicate that those are the very important features. Since here we have the very big data and so many the features, so even we can put the p values 0.01 as well. Okay, if we put 0.01, it says that there are the 70 features. Okay, so basically let's go ahead and select this 0.05 which have 88 features. Okay, perfect. Now out of those the p values, what I'm gonna get here, let's go ahead and get the p-values is equal to the p-values, and these are the new p-value which is just 88, which have just 88 the features. And now let's go ahead and get the index of those p-values. Now these are the index which we are gonna consider during the training and the testing of our model. Okay, so let's go ahead and get the training and the testing the data based on these selected indexes, and that we can get from x underscore train underscore p is equal to x underscore train underscore unique, and there we should get by just calling p values index, and similarly we should get x test p is equal to x test unique. Okay, the p values dot index. Now you see here we have got the training and the testing data set. So let's go ahead and build the model and compare the performance. Okay, so here I'm gonna make a random forest model. So as usual, I'm gonna just make a random forest classifier here. So the random forest classifier take 4 parameter, x train and x test, y train and the y test. Okay, so it has the CLF, that is the classifier, is equal to the random forest classifier which have n estimator 100, and the random state have 0, and the n jobs says that how many core I can utilize while training this model. -1 says that utilize all available core on my computer, and then here I have x underscore train and then y underscore train. Okay, and then I'm gonna get y pred. The y pred is equal to the CLF dot the predict, and then here I have x test, and let's go ahead and print the accuracy. So here I have accuracy with the accuracy score. In the accuracy score I need to pass the original the true y and the predicted y. Okay, so let's go ahead and run this random forest on the selected features x train p and x test p. So here we have x train p, and then here we have x test p, and then we have y train, and similarly we have y test. So let's go ahead and run this and see what is the performance we get. So here we get the 95.3% of the accuracy, and similarly let's go ahead and copy this and run it on the original data set. And if we run this on the original data set, that takes time of the 1.5 second, but here you see the time it is taking the 0.8 millisecond, 0.8 seconds only, but the accuracy is almost the comparable. Here in all the data set, if I put the original data, we get the accuracy 95.85, but here I'm getting 95.3. Okay, so there is 0.5% change of the 0.5% accuracy. And apart from that, the takeaway with this lesson is that, so these are the method by utilizing which you can test your model on your given data, whether it is improving or not. Let's suppose that you have a big data, but in the big data, if there are so many features, in that case, if it is taking a lot of the time, then what you can do, you can utilize these feature selection techniques to reduce the training time. So here kind of the trade-off, the training time is reducing on the selected features, but somehow the accuracy is also reducing very a little. And one more thing, the filter method is not the best way in the feature selection. Just for the sake of your knowledge and for the educational purpose, I'm teaching these filter methods for feature selection. The best method for feature selections are wrapper methods and embedded methods, but those methods are the pretty much the complex and the costly. Although after the 2 lessons, I'll be the talking about the wrapper and the embedded methods. So there you will definitely see there the training gain into the accuracy and reduction into the training time on the selected features. So this is all about in this lesson. Please don't forget to like and subscribe this channel, and you can go ahead and watch other videos on my channel kgp-talkie as well. So this is all in this lesson. Bye bye, have a nice day.